video, we're going to move on to the next big idea. And that's the idea of arc length and sector area. So we've talked about what arcs are. Anytime I put an arc on a circle, I take 2 points on the circle and I kind of represent that part of the curve. That arc has a measure in degrees, but it also has a measurable length. So if I call this point A and this point B, and the center of my circle, let's call it E again. From E to B is a radius of the circle, but from E to A is also a radius. This angle created here, we're going to call it x degrees. That is equal to the degree measurement of arc AB, but there's a length that goes with that, which would be a part of, or a portion of, the circumference of a circle. So the measurement of an intercepted arc, we use the word intercepted arc because it is intercepted by a radius here and a radius here, or intercepted by this angle at E, the central angle. It's a part of the circle's total circumference. Well, that also creates this idea of this section, whenever I kind of put this boundary in with one radius, the other radius, and then the arc, that region has an area that we could measure, and that would be a portion of the circle's total area. And that's the amount of square space taken up in that sector. We call that a sector. Arc length is going to be represented by the variable capital L. We're going to use capital L to refer to arc length. And sector area we're going to refer to as capital S. So this is how we're going to calculate sector area and arc length. If we're trying to find arc length, if we're trying to find the arc length, the length of an arc, we're going to use the left side of this proportion. We're going to use the left side. Okay? Where arc length, L, over the total circumference, 2 pi r, has to equal the central angle measure, we'll just call that x, over 360. I'm going to write that over here as its own little formula. Arc length L over the full circumference, we're going to call that 2 pi r. That's how we find circumference. Has to always equal x, the angle measure, out of a full 360, because the full circle is 360 degrees. That angle we're using is only x degrees, however many degrees we're told to use. But if we are looking for the area of a sector, or sector area, we're going to be using the right side. We're still using kind of that middle portion, that where they overlap, but we're using that part of the proportion to find our sector area. So again, I'm going to write a more simplified version of just that right side. Okay, our sector area out of the full area, pi r squared, has to equal x out of 360 as well. Okay? So, for each of these questions, we are going to give our answer. We're actually only going to give a rounded version of this answer. Okay, we're not going to give a exact answer in terms of pi. But on a lot of these problems, sometimes I just give you the words, but a lot of times I will still give you the picture. So if I've got circle A, mark the center A, with a radius of 14 and a central angle of 132 degrees, I'm going to take another radius and make that 132 degree angle. It doesn't have to be exact, but you should recognize 132, that's more than 90. It's bigger than 90. It's an obtuse angle, but it's still less than 180. I should be able to find the length of the intercepted arc, or arc length, from here to here. And arc length, remember, is that capital L. So I'm using this formula. L over 2 pi r has to equal x over 360. And I'm just going to plug in what I have. So I've got a radius of 14. So that goes into the 2 pi r. I still have my L for arc length, but instead of 2 pi r, I'm going to do 2 pi times 14. You can use the parentheses for that, or you can just do times 14 like that. That has to equal this angle measure, 132, out of 360. Okay? So as we kind of progress forward, to solve this proportion, remember, you cross multiply. That gives me 360 times L equals 132 times 2 pi times 14. To get L by itself here, we're going to divide by that 360 to cancel it. Notice I haven't really done any decimal calculations yet. I'm kind of saving all of that up to put in the calculator at one time. So I can do all of that in the calculator like this. I can do 132 times 2 times pi times the 14, that's the whole top part there, and then just divide by 360 at the end, and I get about 32.3 for that length of that arc. Okay? So we can find the area of a sector kind of the same way. Again, if we're going a little fast, just pause the video and copy things down. But if I mark the center here and I draw a radius again, this circle has a radius of 22 inches. And they want the area of a sector when there's a central angle of 51 degrees. 51, that's less than 90, so we'll just call that 51. So there's my arc, but it creates this sector right there. And I can find the area of that by using this formula. S out of pi r squared has to equal x out of 360, where x is 51, and I already know r is 22. So I'm going to fill that in. S over pi times 22 squared equals 51 over 360. And we cross multiply again, giving me 360 times s for that side. That has to equal 51 times pi times 22 squared. Again, divide by your 360 to cancel that. And so that's what I put in the calculator. 51 times pi times 22 squared divided by 360. We should get 215.4. Okay? As we keep moving forward then, a lot to throw in this first lesson. I understand. Just kind of hang with me. We can do the same idea with these kind of problems, but I'm going to show you kind of the shorter, easier way to do these. We're given a regular polygon inscribed in a circle. Now, regular means all sides are equal, and inscribed means each vertex is on the circle. And they tell you the radius of this circle is 18 for both problems. R equals 18. Now, they want to know the length of an arc, AB, where A and B are consecutive vertices. So consecutive vertices just means right next to each other along the polygon. So in a triangle, any two would have to be consecutive, so I'm going to call one of them A, one of them B. They want that arc length. But I didn't give you a central angle to use here, but there is an easier way to think about this. The length from one point like A all the way around the circle would be the circumference. And circumference is equal to 2 pi r. So even though I don't know a lot of other information, I could find the total circumference. But since each side of this triangle is congruent, each of these three arcs on the outside have to be congruent as well. So AB is the same as these other two. Well, that means there are three equal arcs that make up the entire circumference. So the arc length is equal to that total circumference divided by how many sides that polygon has. In this case, 3. So all I have to do is 2 pi times the radius of 18 and divide that by 3. So when I do 2 pi times 18 divided by 3, I get 37.7 for that length of that arc. Instead of using an angle measure to find out how much of the circle I'm using, I'm going to use the number of sides of the polygon. Let's try that again for number 10. This time there are 5 congruent sides. If I want the length of an arc between two consecutive vertices, A and B, remember circumference is 2 pi r, so my arc length is that 2 pi r divided by 5 sides, which would be 2 pi, I know my radius is still 18, 2 pi times 18 divided by 5. So this time, my arc length is 22.6. Okay? All right, we are getting real close to done. We've just got a couple examples left, so let's finish these up. All right, to find the radius given that the arc length formed by a central angle is approximately 5.76 centimeters and the sector formed has an area of approximately 15.84 centimeters, here's what we're going to do. I'm going to give you a shortcut. If I go back and look here, I know that arc length out of circumference is equal to angle measure over 360, but so is sector area out of the full area. So these two are actually equal to each other. So that's what I'm going to start with. I know that arc length out of 2 pi r has to equal the same thing as sector area out of pi r squared. I can manipulate this formula to solve it for r, and when I do, I get this. And I just want you to make sure you copy this down. If you want to come by and go back over this with me, I can gladly show you where I'm getting this. But if I solve this equation for r, if I get r by itself in this equation when I cross multiply, the pi on both sides cancel, the radius is actually just the sector area times 2 divided by the arc length. That formula is going to help me with this problem because I'm giving you the arc length, 5.76, and the sector area, 15.84. Well, I can plug those in for S and L here. The S is 15.84. I'm going to multiply that by 2 and divide by the arc length, 5.76. So when I do that, I get my radius of 5.5. Again, I'll show you that over here on the calculator. 15.84 times 2 divided by 5.76 is just a simple 5.5. Okay? Same idea on 12. I've given you an arc length of 7.54 and a sector area of 27.14. So again, I'm using the radius formula that radius equals sector area times 2 over arc length. So I'm going to do sector area, 27.14 times 2, divided by arc length, 7.54. So 27.14 times 2, divided by 7.54. And we get a radius of about 7.2. So we went through that pretty quickly. If you have more questions, please go ahead and come on in, ask me for help, send me a message in Canvas. I'll work through this with you. But that completes our first lesson of Unit 6, Day 6.1.